Hi friends, in our last video we have completed Fermat's theorem and some examples. Now we'll see what is Euler's phi function and some properties of that Euler phi function we'll study here. Euler phi function is denoted by phi of n, that is, let n be any natural number. The number of integers less than or equal to n and relatively prime to n is called a Euler phi function. Relatively prime means we know if GCD of those two numbers is equal to 1, then those two numbers are said to be relatively prime. Now the number of integers less than n and relatively prime to n is called Euler phi function and denoted by phi of n. See, for example, phi of 1 equal to 1. Phi of 2 is again 1. That is, only number less than n is that n equal to 2 here. Less than n means 1. 1 is less than 2 and relatively prime to 2. Therefore, that is only one number, that is 1. Next, phi of 3. Phi of 3 is 2. What is that 2? 1 and 2. These are the two numbers which are relatively prime to 1, relatively prime to 3, less than 3 and relatively prime to 3. Similarly, phi of 4 is equal to 2. 2 means there are two numbers. Those numbers are 1 and 3. 2 is not relatively prime to 4 because 2 and 4 have a GCD as a 2. So therefore 2 is not relatively prime, but 3 and 4 are relatively prime to each other. Therefore 1 and 3, these are the two numbers less than 4 and relatively prime to 4. Therefore phi of 4 equal to 2. Next, phi of 5 is equal to 4 because there are four numbers less than 5. That is 1, 2, 3 and 4. These are the four numbers less than 5 and relatively prime to 5. Therefore phi of 5 is equal to 4. Next, phi of 6. Phi of 6 equal to 2. Why it is 2? There are two numbers which are relatively prime to 6. That is 1, 2 is not relatively prime, 3 is not relatively prime, 4 is not relatively prime. Next, 5. So 1 and 5, these are the two numbers which are relatively prime to 6. Therefore phi of 6 is equal to 2. Like this, see here, if whenever you will take that number as a prime number, we are getting that just one number less than that, as that much number of numbers are relatively prime. Suppose if I take 13, phi of 13 is equal to 12 because again 13 is a prime. Since 13 is a prime, every number less than that 13 is relatively prime to 13. If I take 12, 12 is not a prime number. So therefore, the numbers which are less than 12 and relatively prime to 12, that you have to check. First of all, 1, next 2 is not, 3 is not, 4 is not, next 5, 6 is not, 7, 8 is not, 9 is not, 10 is not, 11. So phi of 12 is equal to 4 because these four numbers are relatively prime to 12 here. So here some properties we will check. See that I have written here. If n is prime number, then phi that p is a prime number, then phi of p is always equal to n minus 1. One less than that you have to take. Suppose if it is asked phi of 31. Since 31 is a prime number, so phi of 31 should be equal to 30 because 30 minus 1 you have to write. Every number relatively prime to every number less than that number is relatively prime whenever that number is a prime number. Next, prove that phi of p raised to k is equal to p raised to k into 1 minus 1 divided by p, where p is a prime number. See, this is the theorem. What they are asked, phi of p raised to k is equal to p raised to k into 1 minus 1 by p. We need to prove here, where that p is a prime number. See, I will show you how it is by taking an example. I will tell you. I will take one example. So I will take one number as a p equal to 2, it's 3 I will take, p equal to 3, and another number I will take that k we have to consider. Here this number k equal to, will take it as a k equal to any one number as a 3 I will take. P equal to 3 and k equal to, or else k equal to 2 I will write. So p raised to k, that is 3 square, is 9. So phi of 9 we need to calculate here. So to calculate phi of 9, we need to calculate here phi of 9 we have to calculate, that is the 3 square is 9, that we have to calculate. According to our theorem, what it is given, p raised to k, that is 9 into 1 minus 1 divided by p. P is 3 here. So we will simplify this. What we are getting, simplifying, we'll get it. This is equal to 9 into 1 minus 1 by 3. That is, we're getting LCM is 3, 3 minus 1 is 2, 2 by 3. We're getting it as a 2 by 3. Then dividing 3 3s are 3 1s are, so it is equal to 6. It means phi of 9 is equal to 6. So there are 6 numbers which are less than or equal to 9 and relatively prime to 9. What are those numbers? 1, 2, 3 is not, 4, 5, 6 is not, 7 and 8. These are the 6 numbers which are relatively prime to 9, less than 9 and relatively prime to 9. So therefore phi of 9 is equal to 6 we are getting. So that is what our formula here. This is the formula. So phi of, whenever p is a prime number, phi of p raised to k is equal to p raised to k into 1 minus 1 by p. So that will prove in general. Now see the number of integers from 1 to p raised to k which are not relatively prime to p raised to k are. See what I have taken number as a p raised to k means p square I have written, p equal to 3, k equal to 2 I have taken, means we got here p square and p square is equal to 9 we got. Then we have to write all the numbers which are less than 9 and not relatively prime to 9. The numbers which are less than 9 and not relatively prime to 9 we will take. So those numbers are, see, 9 means 3 is not relatively prime to 9. Next, 6 is not relatively prime to 9. Next, 9 is not relatively prime to 9. So now see these numbers, these same numbers itself, how we can write here? 3, that is p equal to 3 we have taken. So 3 we can write 3 into 1. Next 6 is 3 into 2. Next 9 is 3 into 3. So the numbers up to, if you left the last number, then only up to 3 into 2. That is p into p raised to k minus 1. P equal to 3, k is 2, k minus 1. 1 minus 1 is 0. So therefore 3. These two numbers we are getting. So therefore the numbers which are relatively prime to that, which are not which are relatively prime to that number, not relatively prime to that number we have taken, that is 3, 6 and 9. Now except from 1 to 9, 9 numbers are there. From that 9, these 3 numbers have to leave. So the remaining numbers are relatively prime to 9. Those are 6 in number. So therefore the total number here, the total number of such integers, the total number of such integers which are not relatively prime to p raised to k are equal to p raised to k minus 1. These are p raised to k minus 1 in number. So therefore the phi of p raised to k is equal to number of integers co-prime to p raised to k and less than or equal to p raised to k. That is what total there are numbers p raised to k in number. 9 numbers are there. From that the numbers which are not relatively prime, which are not relatively prime to that 9, that you have to subtract. So p raised to k minus p raised to k minus 1. If I take p raised to k as a common from that, then we're getting 1 minus p raised to minus 1. That is nothing but 1 divided p raised to k into 1 minus 1 by p. So therefore there are totally, if p is a prime number, then phi of p raised to k is equal to p raised to k into 1 minus 1 by p. The next theorem, this is very important theorem. If a and b are co-prime to each other, then prove that phi of ab is equal to phi of a into phi of b. A and b are co-prime, means relatively prime to each other. A and b, these are two numbers which are relatively prime to each other. Then we have to prove that phi of a into b is equal to phi of a into phi of b. See, for that we have to consider any two numbers, a and b, and we have to take the product of those two numbers, that is ab. Now we have to arrange those numbers. The numbers are, first arrange the numbers in b lines, each line containing a number of numbers. See, that is what, how we have to arrange here. I will take two numbers, I will take a and b here. So I will take a equal to 3 and b equal to 4 I will take. A equal to 3 and b equal to 4 will take. Then what will happen? AB equal to, then AB equal to 12. A into B is equal to 12. Now we have to arrange these 12 numbers in B lines, each line containing A numbers. See, like this we have to arrange 1 to 12. 1, 2, next 3. A is equal to 3. Each line should contain 3 numbers. Next 4, 5, 6, 7, 8, 9, 10, 11, 12. See, we have arranged the numbers. Yes, I will arrange them exactly in a column form, so that we'll understand very easily. Now see, there are 4 lines because b equal to 4 and each line contain 3 numbers. There are 4 lines and each line contain 3 numbers here. So now what is the condition? See, like this you have to arrange. In general it is written here. So like this we have to arrange a 1, 2, somewhere here k into a, up to a we have to take. Next number is a plus 1, a plus 2, a plus k, so on up to 2a. That is 2a means here 6 we got, and so on. Last ab is 12. Like this all the numbers you have to arrange. Next what will happen? See, this arrangement is here. Now let us consider the vertical column with which begins with k. Here somewhere in general that we have written, which begins with k. If k is relatively prime to a, then all the numbers in that column are relatively prime to a. See, for example, see here as the 3. 3 is a number, and or 3 is a here. K equal to 2 we will choose. Any one column we have to choose, one number we have to choose, that k equal to 2 I will take. See, this 2 is relatively prime to 3. See, if k is relatively prime to a, say here 2 is relatively prime to 3, then check all the numbers in that column. 2 is relatively prime to 3, 5 is relatively prime to 3, 8 is relatively prime to 3, 11 is relatively prime to 3. Is it? So therefore, what is written? If k is relatively prime to 3, then all the numbers in that column are relatively prime to a, and if k is not relatively prime to a, then no number in that column is relatively prime to a. Yes, here we have 2 columns. Each of those 2 columns are numbers are relatively prime to 3 here. If suppose is there any column in which the numbers are not relatively prime to this a, then no any number in that should be relatively prime to a. So for that I will choose some different numbers I will take. See, for example, if I take a is equal to 4, a equal to 4, and b equal to 5, b equal to 5 I will take. Yes, then ab is 20. Now we'll arrange those numbers. 1, 2, 3, 4. Yes, a equal to 4 means first row contains 4 elements. Next 5, 6, 7, 8. Next 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Like this we have to arrange the numbers here. Now see, a equal to 4. Now see, first column if I consider 1 is relatively prime to 4. So in this column every number 5, 9, 13, 17 these are relatively prime to 4. Next, if I take 2, 2 is not relatively prime to 4. So no any number in this C. 6 is not relatively prime because GCD is 2. 10, GCD is 2. 14, GCD 2. 18, GCD 2. So these not a single number is relatively prime to 4. Next, 3, relatively prime. So every number 7, 11, 15, 19, these are all relatively prime to 4 here. Now see what? In the first row, the last number is 4. These are all the numbers less than, these numbers are less than 4, and from that these two numbers are relatively prime. 1 and 3, these are relatively prime to 4. So there are, that is what the numbers less than that number and relatively prime to 4 means it is phi of 4. There are totally phi of 4 columns, that is 2 columns in which every number is relatively prime to 4 here. So that itself we have to write here. See. Now, first row contains phi of A numbers, number of elements which are co-prime or relatively prime to A. So that is what in this. These in the first row, phi of 4 is 2. So there are 2 numbers in which every column, every element in that column, every number is relatively prime to that number A. That is co-prime, which are co-prime to A. Therefore, there are phi of A columns in which every element is co-prime or relatively prime to A. Now, let us assume that the vertical column which begins with K is one of them, and this column is in AP, the terms of which when divided by B leaves the remainder 0, 1, 2, so on up to B minus 1. Hence, the column containing phi of B integers co-prime to B. See, any one column will consider from that. Yes, so see what you have to do. Therefore, there are phi of A columns in which each element is co-prime to A, relatively prime to A. What we are calculating, the numbers which are relatively prime to both A as well as B, we are calculating. A is 4 here, B is 5. So for both B and A, relative numbers which are relatively prime to both B and A, we are calculating. So now we have to consider only the column heading with 3 and headed with 1. These two columns we have to consider. In this column, we have to divide the numbers by B, that is 5. Then which numbers leaves the remainder, non-zero remainder, those are relatively prime to that 5. Other numbers are not. See, for example, 1 is relatively prime. Next 5, when you divide by 5, remainder is 0, it is not relatively prime. Next 9, when you divide by 5, remainder getting 4, so it is relatively prime to 5. Next 13 divided by 5, we are getting remainder as 3, so it is 13 is relatively prime to 5. Next 17 is the relatively prime to 5. So that is what these reminders. Then these will leaves the reminders is 0, 1, 2, so on up to B minus 1. Up to 4, maximum 4 reminders will come. All these numbers you have to divide. Here the reminder 1, 0, 4, 3, 2. 1, 2, 3, 4. 0, 1, 2, 3, 4 reminders. Next again here you have to divide. For this reminder 3, 2, 1, 0, 4. Every column leaves that reminder 0 to B minus 1. B is 5 here. So like that, B reminder will be B minus 1. Hence, the column contains phi of B integers relatively prime to B. Hence, these columns contains phi of B integers relatively prime to B. Next, similarly, each of the phi of A vertical columns in which every term is prime to A contains phi of B integers co-prime to B. Hence, in the table, there are phi of A into phi of B integers which are relatively prime to A and also to B, and therefore to the phi of, to the product AB. Now see, in which only we have to consider these two columns. So we will consider only these two columns here. Column heading with 1 and column heading with 3. Now whatever these circles I will make, these numbers are relatively prime to 20 also, that will check, because see, every number in this column and every number in this column heading with 1 and column heading with 3 are relatively prime to A. Then I am rounding only the numbers which are relatively prime to 5 also, so that 5 is not. Now I will take 9. 9 is relatively prime. 13. Next 17. Next in this 7, 11, 15 is not. Next 19. Now check these are the numbers, whatever circles I have made, these are the numbers which are relatively prime to 20. Other numbers are not. In this table you check. 5 is not, 2 is not, 6, 10, 14, 18, 4, 8, 12, 16, 20. These are not relatively prime to 20. But 1, 3, 7, 9, 11, 13, 15, so not 15, 13, 17, and 19. These are the relatively prime to 20. So therefore, these are how many number? 1, 2, 3, 4, 5, 6, 7, 8. 8 in number. So therefore, we have phi of 20 is equal to 8. And phi of A is, sorry, phi of 4. A means here 4. 4 is to phi of B. B means 5. 5 is a prime number. So it is 4. 4 into 2 is 8. So that result is verified here. So therefore, you remember this result. Phi of AB is always equal to phi of A into phi of B. But this is holds only for the numbers A and B should be relatively prime to each other. Suppose if A and B are not relatively prime to each other, then this condition will not hold here. The next theorem, phi of n. Yes, it is a formula for in general for any number n. See, by using the definition, we can calculate the phi of n only for the numbers which are smaller number. Suppose the number is very largest one, then it is not possible to write the numbers directly. For example, if I ask phi of 1000, it is not possible to write directly the numbers which are co-prime to n, less than the 1000 and co-prime to 1000. So for that, the general formula. This is again very important for the competitive examinations. The general formula is given that phi of n is equal to n into 1 minus 1 by p1, 1 minus 1 by p2, so on up to 1 minus 1 by pr, where p1, p2, p3, so on up to pr are distinct prime factors of n. Yes, we know according to the fundamental theorem of arithmetic, we can factorize any natural number n can be factorized into product of primes. Yes, and product of primes. So like that, we have to factorize, and these are the distinct primes you have to take. Then I have to apply this formula, that is phi of n equal to n into 1 minus 1 by p1, 1 minus 1 by p2, so on up to 1 minus 1 by pr. We are getting the required phi of n. So that is what, see, we know p1, p2, p3, so on up to pr are distinct prime factors